Okay, some structural properties of ethers. Ethers have two alkyl groups, so you no longer have the hydrogen bond anymore. The two alkyl groups could be the same or they could be different. Usually they are the same. In this case, this is diethyl ether. Let me get my pen again. I got rid of it. There it is. This is what's called diethyl ether. Ethers are kind of easy to name if you have two of the same groups. You just name the groups followed by ether. So since I have two ethyls, it's diethyl ether. This is ethyl methyl ether because I got an ethyl group and a methyl group and an ether, and alphabetically I call the ethyl. Ethers are also bent shaped 109.5 degrees. An ether can be found in rings. This is what's called a heteroatom, therefore it's called a heterocycle because it's a cyclical compound with a non-carbon atom in it. 3-carbon ethers are a special class of compounds called epoxides. Epoxy resins come from these. This is an epoxide. Pretty cool, I think, looking compound, and a huge class of compounds. They're a little bit unstable. I mean, they're not completely, totally not stable. They do exist, and they do exist in nature, specifically in marine life. Plants have a lot of epoxides in them. So here they kind of show an example. I honestly have no idea what this is. I think it's a moth. I honestly don't know what that is. That looks like a moth to me. So I don't know if this is part of their wing. So you got me. I'll have to look in the book and find that out. But hemibrevetoxin B is a toxin that's found in red tide, and they've actually isolated it and checked out the structure, and it's a pretty interesting structure. It's a 6677 ether ring system, a very complex compound. Physical properties, again, it has a net dipole moment, just like alcohols do, but they do not have a hydrogen, so they cannot form intermolecular forces with itself. Now, if you take an ether and you throw it into a little bit of alcohol, it can form hydrogen bonding, but it can't obviously hydrogen bond with itself. So, because of that, they are more nonpolar. They do not really dissolve that well in polar in solvents that have hydrogen bonding, like alcohols or water. So they're more soluble in alkanes and alkyl halides and things like that. They're saying here that they form strong intermolecular forces with van der Waals compounds and very weak interactions with hydrogen bonding. However, because of the polarity, they have relatively higher melting and boiling points than hydrocarbons, but much lower than alcohols because of the lack of hydrogen bonding. All right, so here's kind of a good, I kind of like this because it shows you an alkane, all right, an ether, and an alcohol. And you can see you're increasing in boiling points, but look at how, it just amazes me how drastic hydrogen bonding changes a boiling point. I mean, here is a difference of about 10. Actually, it's almost about 11 and a half. But then to here, it's a difference of 100 to here, 90 from there, or 86, I guess, if you want to be exact. All right, so hydrogen bonding exponentially increases the boiling points. All right, so like we said, ethers are soluble in organic solvents. Low molecular weight ethers, small ethers, are soluble in water to some extent because the hydrogen can hydrogen bond with the oxygen. All right, so here's kind of an example. Here's water showing a hydrogen bond to the ether molecule. This is the dimethyl ether. So like dimethyl ether probably is the only ether that is soluble in water. Diethyl ether is not soluble in water, so that has 4 carbons. So this is a little, I think it's a little high there. I think if you have 2, maybe 3 carbon ether, you can dissolve it in water. But other than that, it ain't going in water. Okay, high molecular weight ethers are not soluble in water. All right. Naming ethers, if you have 2 simple alkyl groups on either side, you just name it with ether and alphabetically. So like this case, ethyl methyl ether or diethyl ether. Okay, Now, if you have a more complex molecule, it now becomes a substituent, and you end it in oxy. Okay, so for example, this is much more complex. So this group is hanging off of my largest chain. All right, so I'm going to start numbering the closest I want to think. So start numbering here: 1, 2, 3, 4, 5, 6, 7, 8. So this is 4-ethoxyoctane. Okay, so ethoxy if it's a substituent, or if you have simple structures, then you just name the two alkyl groups followed by ether. All right, so 4-ethoxyoctane. All right, pretty straightforward. Diethyl ether has been used as anesthesia, like we talked about 100 and what are we talking about? 170 years ago. My God, almost 200 years ago. It was used as anesthesia, which we knew, but like I said, the diethyl ether caused a lot of issues when the patient would wake up. I think a little bit of brain damage and things like that. So they use fluorinated or halogenated compounds now, which are not as bad or harmful. So prior to this, patients had to undergo surgery. So imagine having to go through surgery with absolutely zero painkillers or and being awake. Excruciating. I think this was about the Civil War. The Civil War, I think, was a little bit earlier, and the doctors would do surgery right there on the battlefield, and the patients had no painkiller whatsoever. They, would remove a bullet from a soldier without any anesthesia or anything. I can't even imagine that. It's unbearable. So this was kind of a big deal, and I believe this came out of the Civil War, and he was a doctor that was in the Civil War. And here are kind of the variations. You can see they're pretty close to the same. They both are kind of a kind of an ethyl methyl type ether. See, they all have an ethyl and then one carbon, two carbons and one carbon. But then they vary where the chlorines and the fluorines are. All right, so very similar in structure, just kind of a different isomer pretty much. I believe they're different isomers. That one has 4 fluorines, that one has 4, that one has 3, yeah. So pretty close to the same type of molecule. All right, let's stop right there. When we come back, we will talk about alkyl halides.